Hello students, welcome to the Trigonometry module. In this video, we'll see two examples of verifying trigonometric identities. First, let's verify the identity 1 minus sine squared theta times secant squared theta is equal to 1. To verify this identity, we always work with one side of the equation. Working with the left side of the equation, we see the left-hand side of the equation is 1 minus sine squared theta times secant squared theta. We can write this as 1 minus sine squared theta. And then secant theta is the reciprocal of cosine. So this will be 1 over cosine of theta squared. Now we can recall that sine squared of theta plus cosine squared of theta is equal to 1. This is the first Pythagorean identity. And if I take this sine squared and subtract it, I have that cosine squared of theta is 1 minus sine squared theta, just by rearranging. So this expression over here can be replaced with cosine squared theta times 1 over cosine theta squared. And now I have a cosine squared theta on top and a cosine squared theta on the bottom. They will both cancel out, and I'll just be left with 1. So we've shown that the left-hand side is in fact equal to the right-hand side. We should make one comment that there are certain values of theta which lie outside the domain of secant, which have to be excluded from this identity. So this identity is only true for the values of theta which are in the domain of the secant function. Now, let's verify another identity. Let's verify that cosine of theta over 1 plus the sine of theta is equal to 1 minus the sine of theta over the cosine of theta. So we're going to start with the left-hand side. The left-hand side is going to be cosine of theta over 1 plus sine theta. And then what I will do is I'll multiply the top and the bottom by 1 minus the sine of theta. The reason I can think of this is because I see a 1 minus sine theta on the top of the other side of the equation. I want to try to get that into the problem. So if we do this, that doesn't change anything because I've just multiplied by 1. So what I've done in effect here is this is just multiplying by 1. And multiplying by 1 does not change the left-hand side. So this will become cosine theta over 1 minus sine theta over 1 plus sine theta, 1 minus sine theta. And if we FOIL this out, we'll leave the top as 1 minus sine theta times cosine theta. The bottom will turn into 1 plus sine theta minus sine theta minus sine squared theta by FOILing that expression out. The inside two terms, sine and minus sine, will cancel out. And we'll be left with 1 minus sine of theta times cosine of theta over 1 minus sine squared theta. And now, just as in the previous identity, we know that 1 minus sine squared is equal to cosine squared. So this is 1 minus the sine of theta times the cosine of theta over the cosine squared of theta. And so now the cosine of theta on top will cancel out with the squared. And we will just have 1 minus the sine of theta over the cosine of theta, which is what we wanted to show. And therefore we have verified the identity. So oftentimes we will use the Pythagorean identities to verify certain trigonometric identities, which will simplify problems that are more advanced. Thank you very much.